This is the first board I bought to solve some Wi-Fi Arduino problems. It was inexpensive, $8-9. I bought it from Banggood. Basically, the issue that I had was, in order to use a Wi-Fi module, you have to reduce the voltage pins coming out of the Arduino, because the Arduino pins are 5 volt and the Wi-Fi is only 3 volt. And if you're not careful, you'll burn up your Wi-Fi module. So there's all sorts of kludges that you can do to reduce the power and all sorts of things. And I thought, for $9 roughly, this board would be a good solution to solve the power issue. I didn't really do a whole lot of research on it. I thought for $9, you know, if it works a little bit, I'm happy. Well, turns out the board does not work really at all. I could not get any sort of commands, AT commands issued to it and get some sort of response. I tried flashing it. That was impossible. I guess if I spent more time trying to flash it with new firmware, that might be helpful, but I don't think it'd make any difference. All the reviews seem to indicate that this board fundamentally does not work. Now, there are some breakout pins there below the Wi-Fi chip. I don't know if the cursor will show up here, but right here, there's some pins. Maybe you could tap into those to use this. Maybe you can tap into these pins to use some of the Wi-Fi module here, but the rest of the board fundamentally does not really work. I set these red switches here to different configurations, 1 and 2 up, 3 and 4 down. I tried 1 and 2 down, 3 and 4 up. Made no difference. Number 4 pin, I think, just turns an LED on. One of these LEDs up here. So I'm not really convinced that for the money that this board is even a viable solution. I did contact Banggood to get my money back, and I actually did not ask for my money back because returning the board would cost more to send it to China than it was worth. But they were very nice, and after I sent them a video of it not working, and the problem I had, the description of the problem, they gave me about $7 worth of Banggood points that I can use to buy other products. And I was happy with that. So my recommendation is you might want to steer clear of this board initially when you're starting out with wireless communication and Wi-Fi for your Arduino, because it's difficult to get to work correctly. I imagine if you're really talented, you can get this to work nicely, but it's going to take a lot of work. And right out of the get-go, when I'm in the learning mode, I don't want to have to deal with other issues. That just confuses and compounds the problem. So maybe hold off getting this board until you're comfortable with Wi-Fi communication and setup and flashing the memory, the onboard memory. So anyway, that was my situation and my opinion of this board. So this is the first Wi-Fi module I bought. It is inexpensive and it seemed pretty easy to use. There's a series of pins back here that you plug into the motherboard, and you can use just extender wires and go right into a breadboard and then connect to it that way. The YouTube videos and internet websites I went to suggested flashing these chips with the new firmware, and that was one of the first things you should do. So I tried to do that, and there's some weird flashing programs out there. A lot of them are written in Chinese, and so I'm not really sure what they're doing. But for the most part, I was assured that once you flash it using the straight commands, step-by-step commands, that it would flash. Well, I burned up the first one and blew out the firmware, which rendered the chip useless. So I thought, you know what? all of these wires that you have to connect and flashing and all that seem to be more than what I really wanted to deal with. So I looked for a development board, which is this one. And you plug the Wi-Fi module back here, and this takes care of all the power issues supplied by the USB port here. The primary issue with Wi-Fi modules is that they only use 3 volts, whereas your Arduino and USB ports provide 5 volts. And what will happen is you'll wind up blowing out your chip, your Wi-Fi module chip. So this board here allows you to plug the Wi-Fi in and put this device, this little mini developer board, into your USB and issue AT commands. And the commands are these, all these AT commands. If you issue it using your Arduino IDE, and you don't have to have a program running or anything, you just plug in the USB, start up your Arduino IDE and open the serial monitor, and then start typing these commands, and you'll get responses back from your Wi-Fi module. So that, for me, solved a lot of problems right off the bat, as far as being able to access and actually use the Wi-Fi module here. However, the USB port right here, you can't use your Arduino with that, at least not very easily and not directly. So then I looked online and found this other development board, which comes as a kit, and there's 2 of them. There's the development board with the pinouts for you to plug into Arduino breadboard and then connect the Arduino to it, and then also a Wi-Fi module. And the price here is a very good price. So I got to get another development board and replace the burned out Wi-Fi module. And that, for me, was the best solution. You actually need 2 boards. One as a development board that you plug into your USB to kind of access the chip, to kind of test it, to see what firmware you have, that sort of thing. And then this board here, which allows you to connect it once you're done and you've written your code. You can then use this to plug into your Arduino project and control it through Wi-Fi. So those 2 boards in conjunction with the Wi-Fi was the best solution if you're just buying a Wi-Fi module. You open up your Arduino IDE, and you don't need to load a sketch or anything. You click on the serial monitor here, and you must change the line ending to be both line return and carriage return. Once you've done that, and I leave it at 6900 baud, you can start issuing some of these AT commands. Here, this is just a general test. The first one here is just AT. You enter AT, and it'll give you a response. It doesn't show it here, but it'll give you a response, OK. So let's try that. I have plugged the Wi-Fi module into the USB development board, and I plugged that into the USB port on my laptop, and you get a little red light indicating that it has power and it's ready to go. Make sure your cap lock is on, because it has to be all in capitals. You type AT, hit enter, we get an OK. That seems like at least we're communicating with the board. So let's check the firmware version. We do AT plus GMR, all together, one long string, and it gives us the version, AI thinkers, the date, the time, and then an OK. So all of these commands over here, and there's many more, you can issue at the command prompt using your Arduino IDE. Now, one thing you do need to do is you need to know the COM port of your board, because you have to enter the port number right here. Mine's COM18. And I found that by going to the device manager and looking under ports. And it will come up, at least mine comes up as USB-serial CH340 COM18. And so I just select COM18 and issue a command, the AT command, and away and off you're going programming this little module. This for me solved a lot of the voltage issues, and it allowed me to start to learn how to use AT commands with the Wi-Fi module. It was a very simple, straightforward solution, and I could use the Arduino IDE, which I'm very, very familiar with, and I'm sure you folks are too. So this was the first step to becoming familiar with Wi-Fi and Wi-Fi modules. This was my first board I purchased that is a Wi-Fi SoC, SoC, which stands for System on Chip. There's a full Wi-Fi chip here and an antenna and then some logic here that allows you to connect these pins and have data in, data out, and that sort of thing. You do need to have a special USB cable here, and it looks like this. It's pretty straightforward. It's a simple little cable, but it has a connection here that's kind of difficult to come by. It's nice that it's a short cable and it plugs into your USB, and it's only 80 cents. So when you order your NodeMCU module, and I got mine from AliExpress, it was only $2.85. You order the cable with it, and you can plug it in, and away you go. It's pretty straightforward. This allows you to do more coding using your Arduino IDE and actually get input and output as opposed to issuing just straight AT commands. But it's a little tricky to set up, and I'm hoping I can kind of explain this without it being too confusing. Once you open your IDE, and I've loaded the Blink sketch here, which, like it says here, it's the ESP86 Blink by this gentleman here. It blinks the blue LED, or you can hook up a red LED or whatever color you want in addition to the GPIO1 pin. And basically, it's just a simple little sketch to kind of get you used to programming and making sure you can upload code to your module. But in order to get your module to work, there's a couple things you need to do. First, you need to go to your preferences, and you need to install this line right here into your preferences. That allows you to get access to the ESP8266 library and boards and that sort of thing. So once you've done that, you then go to, let's see, you go to include library. Not include library, I'm sorry. No, you go to let's see, where is it? It's here somewhere. Yes, I think it is include library. You go to the top and you go into manage libraries, and you want to type here okay, there we go, ESP8266, and when you hit enter, it will come up with all the different ones that libraries that use the ESP8266, and there's one in particular you definitely want to install. It is this one right here, the ESP8266. I have mine installed, so I'm not going to reinstall it. But once you install that, you then can select the board, and you go down to the board here, and the one you want to get is the NodeMCU 1.0 ESP-12E module, which is down here at the bottom. It's this, that's generic, that's the wrong one, hang on. Here it is, right here. The NodeMCU 1.0 ESP-12E module, not the 12. If you order this board from AliExpress, I believe they send you a 12E version. You'll have to see which one works best for you. After you do that, you need to set up the COM port. And to find the COM port, you go to your device manager and you select the ports option. And listed there will be the USB-serial CH340 and then your COM port, and my COM port is COM18, so that's the one I select. The rest of these speeds, you just leave. I didn't change any of them, the 80 megahertz, the flash size, or the speed, 115 too. I just left it. And then once you do that, then you're pretty much ready to upload code from your Arduino IDE to your module. And basically, when you do that, you'll see down here that the response is slightly different than normal Arduino IDE uploads. Just to go over this code, this Blink code was a library I downloaded along with the module, so it's a readily available Blink module. I suggest getting the one by Peter Simon. It basically sets up the LED built-in pin for output, and then the LED low turns it off and then turns it back on, and it just cycles on and off. And here's the explanation of how that works. That's not what I'm trying to focus on here, because you can write any code you want. What I want to describe here is now when you go to hit upload, you'll see that it takes a little bit longer. It's not quite as fast as the Uno or the Mega by Arduino. But it does eventually get uploaded. And you can see it's still compiling the sketch here. And the bar is going. And you always get some sort of weird message here at the beginning. And then you get the nomenclature you're familiar with. What's unique is this dotted line going across, and it'll give me a percentage here at the end, like 33 or 35% or 36%. And then it'll be multiples of 36%. And eventually it'll say done, 100%. And then at that point, your code is uploaded to the board. And then you can start using the board any way you want. And here we get the done uploading message. I don't think there's anything on the communication port. I did set this for, you got to set it for both, I believe, the line return and the carriage return. Not sure that is absolutely necessary. Again, I have not done a whole lot of extensive coding with Wi-Fi. But at this point, you've uploaded your sketch to the Wi-Fi, and you're good to go. So that's as far as I've gotten with this module. My next step will be to find out how to actually read the Wi-Fi output on my laptop's web browser. And in order to do that, you need to find out what the IP address is. So that's kind of the next step. And then you're communicating with the board, and you can get it to do all sorts of things from there. The last and final Wi-Fi board that I wanted to show you, or Wi-Fi module that I wanted to show you, was this one, or is this one, the Arduino Uno Wi-Fi microcontroller. I wanted to be able to use the Arduino IDE and Wi-Fi together, and I want to do that seamlessly and easily. You can buy other modules like I shown earlier and connect them with wires to pinouts on the Mega or Uno. But this was a much cleaner solution. And in addition to not only getting a new Uno board, but you also get Wi-Fi integrated, and that it comes in at about $35. And it was hard to find. Robot Shop was the only place at the time I bought it that had it. It looks like they have more in stock now. But for me, this was the best and cleanest solution. And this allows me to do all the other little functions I want to do with Wi-Fi, but built in a much cleaner package. So that being said, it was a little bit tricky to get it to actually kind of work and set up because there's not a whole lot of information. And that's what really prompted me to do this video, even though I haven't really done a project yet. But I will do a lot more projects with this. So that being said, let me show you the libraries that you need to download and install. The first thing you need to do is you need to flash the memory module on the Uno. And to do that, there's some files you need, or a file you really need. The one you really need is the Uno Wi-Fi Updater - Arduino IDE plugin. And what that does is it gives you these options right here. This I added earlier, but this is the one you need to update to the most current version of the firmware. And in order to get this option, you extract this zip file, and it will create a tools folder. And you take that tools folder and you add it to, it'll say, you open it up the tools folder in this zip file, and it will say Uno Wi-Fi. And you take that Uno Wi-Fi folder and you put it in your Arduino tools directory, not the library directory, but the tools directory. And then when you restart the IDE, you will get the options here to flash it. And I recommend flashing it when you're comfortable with the board and it's functioning correctly, but you should definitely flash it. Now, that being said, in order to flash it, you have to close that down. You have to use a new version of the IDE. And I was using an enhanced release for Windows 1.0.5 for many years. But it seems that in order to do Wi-Fi, you need a lot more features. And so the 1.8.2 is a good choice. I had some problems with it. It stopped recognizing the Wi-Fi data included library commands. So I think I still need to work on that a little bit. So I would say if you can figure out how to use the library, because I would compile it and I would get an error message saying that this was not declared or not it was an illegal variable. So then I downgraded to 1.7.11, and this does not have the flashing capability. So I used the 1.8.2 to flash, and then I installed 1.7.11 in order to do my coding, because then it actually recognized this included library, and it compiled correctly with no problems. So I still have some work to do figuring that out. But all in all, the 1.7.11 works great. Once you flash the firmware, you really don't need to do it again. So I'm not so sure I'm going to migrate to 1.8.2. That being said, one new feature are these line numbers that you can set. I really like that. I like being able to have the line numbers. I think that's a nice touch. And you do that in the preferences over here in File, in the preferences down here. There's an option for line numbers. I believe it's display line numbers right there. So I find that to be this new IDE version to be pretty stable. I wrote a little code here to flash to the new Arduino Uno Wi-Fi module or board. And basically, it's real simple. I include the Wi-Fi libraries here. I set it to 9600 baud. I say, please enter a number. I wait for the ESP serial to get that character in. I read that character, and then I just echo back to the ESP serial console. You entered, and then the command, not the command, but the character, and then I say done, and then I stop. Now, what exactly is this doing? Well, what's interesting is you can see down here, I've selected the Arduino Uno Wi-Fi board, which you need to do right here, and you can see there it is right there. So you select the Arduino board, and then you need to set up the port. And what's interesting, you actually have 2 ports for this Wi-Fi. You'll see that I have one here on COM port 19, which you can go to your device manager, look under ports, and you'll see your COM port with the Arduino Uno Wi-Fi listed. That is actually the USB serial cable going to the board to supply power. That's how, that's one way to upload your code and communicate to the board. You also notice there's network ports, which is a whole new feature. And it says the Arduino this is my port right here on my local network, the Arduino Uno Wi-Fi. You can also select this as your board, and you can upload over the air. And there's it's called OAT, over air transmission, or something like that. That's the acronym that allows you to communicate using just Wi-Fi to update your board and communicate with your board. And when I say communicate with it, if I select this no longer will work. This board doesn't see, it says it doesn't even recognize the serial monitor. Well, if that's the case, then how do you see your output? Well, if you go to that port address, that IP address right here, well, actually just those, and then this comes up, you get this new web screen. And this is actually, the IP address is on the Wi-Fi, the Arduino Uno Wi-Fi module. And this has all sorts of different bits of information. You can see your connectivity, this sort of thing. And then you have this console, which is displayed. And if I click reset, it says please enter a number. And then here where you enter text, I'll enter 1. Now it's going to come back with an error. Or not an error, but it's going to say it's a different character. It says -1, but it doesn't matter what you enter. I'm just capturing a character, sending it to the board, and then echoing it back. That was my primary goal here, was to communicate via Wi-Fi between the laptop and the Arduino Uno Wi-Fi module or board. So here I can clear the console. I reset it. This is like hitting the reset button on the board. I enter a number. It doesn't have to be a number. I can enter an let's do a capital A, and I hit enter, and it'll convert that into a digit also. It doesn't matter. I'm not really doing any processing. I just am trying to communicate. So that basically is how you can communicate between your Arduino Uno Wi-Fi module and your PC. There are some Wi-Fi connectivity issues. You have to have this in, there's what's called STA module, or STA mode, and it says here, switch to AP and SPA mode to enable network selection. So if you want to log into your local network, you've got to switch the mode. And AP stands for access point, and SPA stands for station, or Wi-Fi station, I believe is kind of what it stands for. I'm a little bit off on it. It's SPA, something like that. So, but basically, it has a dual mode. Instead of being an access point or just a station, you need to be in both. And so to switch, you click here, and then it'll switch. You'll see it says STA here, and sometimes you get an error message. But if you go out and come back in, if I go to console and then I go back to Wi-Fi, now it's switched. And I think this has something to do with communication. So now I can actually change some of these networks here and give the password and log into a different network. Now mine here is just Netgear. So I'll go back to STA mode, and now I can communicate with the Arduino. That, in a nutshell, allows you to communicate and send data back and forth between your Arduino Uno module and your laptop. And that's all done here. This allows you to at least find out what port to put in your web browser. That took me a long time to kind of figure out exactly why I was losing my connection, my web browser. It wouldn't come up. But once you set this in your web browser here, up here, then you can go to your Wi-Fi setting and select a different network, like your local house network if you want, your home network. And then you can connect to other devices in your home network. Otherwise, your laptop is connecting directly to your Arduino module, and you can't control any other devices that you may have in your house. So I hope that this is at least a beginning explanation on how to use this Arduino Uno Wi-Fi board and start to use Wi-Fi capabilities in your projects, because the IoT, the Internet of Things, is a huge field that's coming up, and that paired with robotics, which is also another huge field, is really important. It's so important, I think, that I've actually upgraded my IDE and all sorts of other projects now to include Wi-Fi. So I hope that this video helps you. I encourage you to share it and subscribe to my channel, and hopefully in the future I will show you more of these projects that I'm doing using Wi-Fi and other robotics.